Hello class, I'm going to go over the class activity we did the other day and go that in more detail. So the goal in class was to calculate the density of cardboard. However, we didn't just want to use one measurement. We could just take one piece of cardboard, measure the radius, weigh the mass, calculate the density, and be done. The reason why we did it with 5 different data points is to make the calculations for density more precise. And so to start, we start with the equation for density. The common variable used is rho. I'll use d this time just to make it a little bit easier to follow along. So d equals mass over volume for density. Now we're calculating or we're measuring the mass and the radius for the cardboard. However, we only have the volume here. So the volume for a disc is, I'll write this out, is pi r squared times h. So this is the volume for a disc that we're measuring. Now we have mass and we have radius. The next step we want to do is we want to make this equation look like a linear form. We want to make it look like the slope equation, y equals mx plus b. To do that, we're going to say that mass over here is going to go into the y slot, so that will go into the y slot. And then this r squared quantity, this is going to go into the x slot. Now let's just rearrange this equation so that everything's on one line. We're going to put this quantity on this side over here. So we have mass equals, I'm going to write pi h d times r squared. So what I did is I just took this quantity, put it on the other side of the equation, and I kind of rearranged the variables a little bit in a different order so that the m is in our y slot, so this is in our y slot, and then this r squared is in the x slot. Now for b is going to be 0 for the y-intercept, so we don't need to worry about that. And then what's in the slope slot? This quantity right here. That quantity, these constant variables, are in the slope slot. Now let's look at an example of a graph over here. Let's say we have a graph of y equals, let's do mx squared. If we were to graph that, if y was on this axis and x is on this one, we would get a parabola. Now the problem with the parabola is we can't calculate the slope. So in order to calculate the slope, what we need to do is call something called linearization. And so what we're going to do to make the parabola into a straight line is to square the x. So if I took the data points value of x squared instead of just x, and y is the same number, your new data will look like a straight line. And now we can calculate the slope. You can pick 2 points, and you can do rise over run to get some number for the slope, whatever that number represents. Now, what is in the slope slot? These variables right over here. All right. If we were to take this equation, instead of writing it y equals mx squared, let's write it in this format. So in the y slot, we have mass. Over here, in the slope slot, we have pi h d. In the x slot, we have r squared. So if we were to make a graph of m and r squared, we would get, oops, sorry, not r squared, r. Let me erase that. We would get a parabola, just like this. And to make it into a straight line, what do? mass, the y value stays the same, which is mass in this case, and then with the r, we square it. So now, if we were to plot the graph, we would get a straight linear line. And we can calculate the slopes by taking 2 points and figuring out that number. The slope for this equation here, in the slope slot, is pi h d. So we have slope equals pi h d, which stands for density. We can calculate the number for the slope by doing a rise over run. And if we measure the h value, the thickness of the disk, we can calculate what the density is. So density equals slope all over pi h. And we get some number for the density of cardboard. This problem is an AP problem, and it's definitely a question that would be on an AP exam test. However, they wouldn't use density, they would use some kind of other equation. I believe for the classes today, everyone got around close to 10%, either above or below 10%. If you have any questions, please come see me or send me a quick email.